Hello everyone, welcome to the 2025 AMC 8 problems. Today we're going to discuss problems 18 through 22. So let's get started. Problem 18. The circle shown below on the left has a radius of 1 unit. The region between the circle and the described square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the radius is shaded. The shaded regions in the two circles have the same area. What is the radius r in units of the circle on the right? So by symmetry, each of these four regions is going to have the same area, which means this region is going to be equal to 4 of these smaller regions. So 4 times this. One thing to notice is that these two regions are similar, meaning they have the same shape. You might have heard the word similar in similar triangles. For example, these two triangles are similar because they're the same shape, just different sizes. So since this has the same shape, we can find it by the ratio of the areas. So if this region has 4 times the area as the smaller region, then the size is going to be twice as big as this region. Similar to how a square with 4 times the area has 2 times the side length, which means the radius is also going to be double of this one. So r is going to be equal to 2b. Problem 19. Two towns A and B are connected by a straight road 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles from 25 to 40 to 20 miles per hour. Two cars, one at town A and one at town B, start moving towards each other at the same time. They drive at exactly the same speed limit in each portion of the road. How far from town A will the two cars meet? So I'll just draw these two. So the speed, this one is going to be 25, 40, and 20. So time is going to be distance divided by velocity, which means if all these are 5 miles, then 25 miles per hour, this time is going to take, time equals 5 over 25 hours. 1/5 of an hour is 12 minutes. Similarly, for this region, the time is 5 over 20, which is 1/4, which is equal to 15 minutes. Which means that car A, car B is going to get to this point 3 minutes earlier than car B gets to this point. So when car B gets to this point, car A will already have traveled maybe, let's say here, for 3 minutes. And we want to find this distance here. And we, instead of t equals d over v, we do distance equals velocity times time. And 3 minutes times 40 miles per hour. 3 minutes is just 1/20 of an hour. So this equals 2 miles. So this is 2, which means this is 3. So at time equals 15, A is at this location and B is at this location. Since they travel the same speed towards each other, they will meet at the midpoint right here. They're asking for, first of all, this is 1.5 and 1.5. They're asking for the length from A to this midpoint. So the total distance is 5 plus 2 plus 1.5, which is going to be 8.5 miles. So the answer is D. Problem 20. Sarika, Dev, and Rajiv are sharing a large block of cheese. They take turns cutting off half of what remains and eating it first. First, Sarika eats half of the cheese, then Dev eats half of the remaining half, then Rajiv eats half of what remains, then back to Sarika, and so on. They stop when this cheese is too small to see. About what fraction of the original block of cheese does Sarika, which is the first one, eat in total? So Sarika is gonna first eat 1/2, then Dev eats 1/4, then Rajiv eats 1/8, and Sarika eats 1/16, 1/32, 1/64, and so on until it's too small to see. Really, this means that you add until infinity. So you notice that each time Sarika eats, it goes down by 1/8. So the first one is 1/2. The second one is 1/16, and the third is 1/128. So this is just an arithmetic or geometric sequence with common ratio of 1/8. And we know the sum of a geometric series is the first term divided by 1 minus the common ratio, 1/8. We do some simplification, and we get 4/7 is the answer. Another way to do it is to notice that these three are the same ratio. So you can actually find how much they eat at this stage, which is 7/8. And this is the running total of this stage of the cheese. So Sarika eats 1/2, and you can divide that by the 7/8 of the total, which again gets the same answer, 4/7. So it is A. Problem 21. The Königsberg School has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. The school noticed that each pair of connected pods has been assigned grades differing by 1 or more grade levels. For example, grades 1 and 2 will not be in pods directly connected by a walkway. What is the sum of the grade levels assigned to C, E, and F? I believe this should be 2, not 1, because it just makes sense that way. So the first thing to notice is that C and F both have 5 walkways connected to them. And this is important because if you were to choose a random number, let's say 3, and assign it to C, then that wouldn't work because A, B, F, D, and E are the neighboring pods. That wouldn't work because it can't be 2 or 4 because they're adjacent. So you would have 1, 5, 6, and 7. But this is only 4 walkways. So you can't choose 3. 3 can't be C, and the same logic goes for F, which means C and F must be the edges, 1 and 7. For example, if C was 1, then the neighboring pods would be 3, 4, 5, 6, 7. So the same thing applies for F, which means we can just assume that C is F and C is 1 and F is 7. If this doesn't work, we can just switch them around later. So the number 2 must be the one in G because A, B, D, and E are all adjacent to 1, which does not work. And similarly, D must be 6 because it's the only pod that's not adjacent to 7, which is F. And now we're left with 3, 4, and 5. And since A and B are adjacent, A and B must be 3 and 4, or 3 and 5 in some order, which leaves E for 4. And more specifically, this is the arrangement that works. So we're just looking for E plus C plus F, which is 1 plus 4 plus 7, which equals 12. So the answer is A. Problem 22. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there are the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there's at least one coat and at least one empty hook. How many different numbers of coats can Paulina's pattern satisfy? So we just start with this rough outline. So if the spacing is 2, then there are 2 coats here between every space. But we can just add one last coat here to make this a complete multiple of these patterns. So instead of 35, there are now 36 that have some group. So if there are X groups and Y of these locations in every group, then X times Y is equal to 36. So we just want to find the number of factors of 36. We could list them out, or we could use the formula. This is equal to 36, which means there are 2 plus 1 times 2 plus 1 equals 9 factors in 36. And this comes from 2 having the factors 1, 2, and 4, 3 having the factors 1, 3, and 9, and each of these factors can be matched in some way. So there's 3 times 3 equals 9. But the answer is not 9 because we can't have X equal to 1 or Y equal to 1, because then there would simply be either a bunch of coats in a line with no empty spaces, or you would have a bunch of empty spaces with a thing at the end, or a coat at the end. But this coat doesn't actually exist because, as we stated before, this is just added to make the pattern easier. So in the real thing, this would just be a line of empty coats, which both of these do not satisfy. So we actually have to subtract 2 from my answer to get 7. So the answer is D. Alright, thank you guys for watching. I'll see you in the next one.